For this video I decided to test some configurations that can help an operating system under load to perform more efficient. Those configurations at first are work for Windows Server machines, but they can be useful for our users that we use Windows client systems and we don't work on Windows servers or something. So we can use those configurations in order to improve the efficiency of our system under load when the system usage is high, the memory is high, and the disk I/O is high, and so on. Those configurations are probably famous for the most of you, but I found them from a discussion in Guru 3D that the MBK user suggests to apply individually those configurations and test them under load to see if we can trace any improvement after we applied those configurations. All the things that you see has documentation. For instance, the maximum tunnel entries, on that case we're disabling this feature, we can find it in this document from Microsoft. This document is back to Windows Server 2008 and trying to help you tune your Windows Server 2008. Those configurations that you can find here, you can use them, and the most of them we still use them on Windows 10 and Windows 11. So you can take all this information and test every single thing inside of this document, and probably I will look even deeper on this to make some videos. Anyways, if we for instance search about this entry, we can see the official statement. At the end of this video we have the documentation of this document. Some documentation may not work because this document is old, so the links maybe not exist anymore. So let's discuss about the configurations. About maximum tunnel entries, in our case we're disabling completely this feature. By default we used this value 1024. Lowering this value will reduce the size of the NTFS tunnel cache. The NTFS is a mechanism of Windows that developed by Microsoft and is responsible for storage jobs and which can greatly improve file deletion speed in directories with many files. However, be aware that some applications rely on the NTFS tunnel caching, so if we lower the value or even we disable it, it can cause some issues. About the additional critical work threads, first of all, before we explain it, those two configs are related with the logical processor. So by default, the system, those two features by default using only one logical processor. We want to use all those processors to improve the efficiency of our system and speed up some tasks of Windows. So the concept is to set the maximum number of logical processors, but you can decide which processors that will get applied. I mean, you can set 2 processors, 3, 4, between 0 and the maximum number of logical processors that are supported on your CPU. So the default value is 0, meaning no extra critical kernel work threads are added. The setting influences how many threads the file system cache uses for handling read ahead and write behind requests. So by using more kernel worker threads, we can speed up the handling of read ahead and write behind requests. Increasing this value can improve I/O performance by allowing more acute operation, especially on systems with many processors and strong storage hardware. Additional delayed worker threads. This setting increases the number of delayed worker threads for a specified work queue. Delayed worker threads handle non-urgent tasks and can have their memory paged out while waiting for work. To automate this procedure and set automatically the max number that is supported for your system, you can use this script that is not mine. It's made from prd.gy.ace, and if for instance I want to execute this from cfd and go to the registry, as you see, the hexadecimal is the decimal is 12 and the hexadecimal is this value. So by default those values are on this path and have the value 0. So you change those values on the max number of your logical processors that you supported. So let's get back here. The dynamic tick. Dynamic ticks are a feature that lets Windows stops the system timer when nothing is happening in order to conserve power. So it's a type of power save. The distribute timer. We have already seen this before, but I wanted to remake this video with more precise measurements and data. And this is from Windows Internals Part 1 6th edition. And theoretically, this feature helps improve performance on servers using Hyper-V and any system under heavy load, like a system that streaming and play a game and using Discord, using Spotify. Typically, CPU 0 manages most timer tasks. So CPU 0 is responsible for the most heavy tasks and basically handles the most of them. And to prevent this load to be only on one CPU, you want to share this workload to all of your available CPUs. So CPU 0 manages most timer tasks, which can cause delays and slowdowns, especially with multiple virtual machines. By spreading these tasks across all CPUs, the load is balanced, reducing latency. This behavior is controlled by the KI distribute timer setting, which you can adjust by changing the distribute timer's value in the registry at this route. And now we're ready to proceed in the performance analysis. The conditions is the same, the FPS part, the latency, the tools that I used, the hardware, the operating system, and the games. Starting with Fortnite Latency, we have the direct kernel. We can't say that we have any improvement, any huge improvement. I mentioned with the green color the best values, the lowest values, the lowest execution times for specific situations. I tested everything individually and I tested all tweaks together, and obviously I tested without those tweaks. The NTFS driver, we see when we disable this feature that is related with NTFS, we can't say that we have some huge improvement. We have some improvement by all tweaks together, and as you see, duration fragment is better with all tweaks together, and the other metrics are better with increase the number of kernel threads. We already talked about this. The Endos kernel again is actually not so affected from those configurations. The MD driver, same. The system tolerance actually again is almost the same. Can't say that we see anything worse or anything better. The CPU usage is lower in seconds. In disable NTFS tunneling, and the CPU weight is better by default without changing anything. In CS2 latency, we follow the same pattern. The direct kernel doesn't seem to be affected from those configurations, and maybe makes sense. The NTFS has some improvement with distribute timers. We can't say that we have any huge improvement by disabling NTFS tunneling, and same thing for all tweaks together. Again, we see something very similar in all cases. The Endos kernel same, and the AMD driver again doesn't seem to be affected. The system latency tolerance is very close in all cases. The CPU usage is again very close, and the CPU weight again is close between every option. In Fortnite FPS, we have some boost by disabling NTFS tunneling in 0.1% lows, We can talk about almost 10 FPS in some cases. But on the other metrics, we can say that we have some improvement. So, can we be sure about we can take 10 FPS by only changing this? I don't know. The PC latency frame times AC dev, it's actually the same in all cases. In CSGO, we follow the same pattern. We have some improvement in all together when we talk about 0.1% loss and 1% loss, and some improvement in when we disable dynamic tick. Actually, we don't see anything in terms of FPS. Same thing for PC latency, frame times, and STDev. The PC latency is actually the same in all situations. It probably makes sense because the metric is from frame view and I don't know how precise it can be. So, what to do now? Should I use anything from what we saw? My answer is some of them maybe can be good. It depends what you want to improve. On some cases, on some specific tasks, it can be very useful. But as the post says, always behavior under load. You need to test this part. Maybe when you do benchmarks and tests, when you're streaming, when you play, when you do multiple things, you may see some improvement by doing those configurations. On my case, especially in FPS part, I can't say that we have any improvement. From the other hand, the latency again is actually the same. Maybe in some cases we have some very small improvement, but when we talk about microseconds or so small numbers, it's useless to change something. It's not necessary, probably. Anyways, thanks for watching, guys. Tell me your thoughts below. Tell me if you saw an improvement, if you have tried those configurations, and we'll try to respond.